In this video, I'm going to discuss about karst topography. So, karst is a topography formed from the chemical weathering of limestone, dolomite, and gypsum by surface and groundwater. Among this, limestone is the major landform regions. Wherever limestone is there the groundwater erosional capacity increases. Whether when we compare it with the dolomite and gypsum, and the karst, this is derived from word kras, which is German word, which means it is barren and stony. The features of the surface, on the surface where the karst topography is there, the feature on surface will be, it will be very corrugated and rough landforms. Not even, it's like a rough or corrugated undulating landform. And subsurface, it can have many caves, stalactites and stalagmites. Example, the Nullarbor Plain in Australia is the world's largest karst landscape, and in the regions of Yugoslavia, Slovenia, and Iceland, in these regions we can see many those limestone regions we can see many karst topographic landform overall. But in throughout the world, the karst topography is distributed everywhere in all the continents. What are the conditions required for development of karst topography? So the limestone should be the rock should be very massive and thickly bedded, hard and well cemented and well jointed, because in these rocks, it can well jointed rocks, through those joints the water can enter and it can alter the limestone topography and can form karst topographic landforms. Features and porosity, it should be a non-porous limestone, because if it is a porous limestone, then enter the water will enter through all the pores of those rocks, and it will collapse the rock structure entirely. But if it is well jointed rocks, then the water will enter through the joints only, and it can form various landforms in those regions. And the position of rock should be above the groundwater table and close to the ground surface, so that suppose this is the groundwater table and this is the surface, and this is the saturated zone, but here this is unsaturated zone. When it is flowing, the water is moving towards the groundwater table, so the movement of the water enables the water to dissolve the minerals, whichever dissolvable minerals which are there, and so it can form many land features. And distribution of limestone should be widely distributed both in varial and vertical dimension. Structure should be the limestone structure, it can be highly folded or faulted rock features, and adequate rainfall is necessary for the development of karst topography. Erosional, first let us see about erosional landforms. So karst topography is because of the rainwater and groundwater. And first let us see erosional. These are formed because of erosional and depositional features of these groundwater. First one is lapis. So these are highly corrugated rough limestone lithology. So we can see here, this is a lapis, image of lapis. It's highly corrugated and rough. The surface is rough, and low ridges and pinnacles, narrow clefts, and numerous solution holes is called lapis. So we can see a lot of solution holes are there, and the pinnacles on the top and clefts. So these form, this is a corrugated landform. Roughly, if we say this is a corrugated landform, and the other names for these lapis are called Klins, Bogus, Karen in German. So that's how they call it, as in different language they call it lapis as Klins, Bogus and Karen, and formed due to corrosion of limestone along its joints if the limestones are exposed to the ground surface well. So here this is a ground surface. This is the ground surface. These rocks are limestone rocks. When the rainwater flows through through the joints, they just dissolve those minerals and form this kind of corrugated landforms. So in this image we can see the other landforms like Uvala, Doline, Polges and Swallowhole, Sinkhole. So depending upon the size of these structures, it has different names. Let's see one by one. First one is solution holes. This rainwater with dissolved carbon dioxide dissolves limestones along their joints and forms numerous types of solution holes like sinkholes, dolines, etc. the ground surface. So smaller holes are called sinkholes, but if it is larger hole, they are calling it as a dolines. So these both are sinkholes. solution holes. These both sinkholes and dolines both are solution holes because of dissolution of carbonate rocks. And these sinkholes are funnel shaped. These sinkholes are funnel shaped and cylindrical shaped, and depth can be up to 3 to 10 meters. Area is about few square meters to acres. Whereas the swallow holes, these because these sinkholes coalesce because of coalescence of these several small sinkholes form a larger swallow holes, and they enlarge due to dissolution and form dolines. If they enlarge due to collapse of upper part, they call it as collapse sinks. So depth can be up to 300 meters, diameter can be up to 1000 meters. So here we can see that sinkhole, the dimension of the sinkhole is small, whereas the dolines, so the dolines diameter and the swallow hole diameter, so this we can see that, so it's a larger dimension when we compare it with sinkholes. So sinkholes are smaller in dimension, dolines are larger in dimension. So here we can see many dolines here, so these are larger in dimension. In solution pan, it appears like dolines, but these are shallow in depth and larger in aerial extent. Dolines can be up to 300-meter depth, but the solution pan, it is very shallow but appears like a dolines itself. Aerial extent is large, but the depth is less when we compare it to dolines. And the karst lakes, these are formed due to plugging of floor of dolines with clay and prevents water penetration. This filled with water. So suppose this landforms, suppose this is a large landform, this is a large 1000-meter large square meter large landform, but the bottom surface is filled with clay. Then the clay holds a lot of water. It prevents the penetration of water towards the ground surface, so that it can hold water, and the clay can hold water, and above that clay also there is water. Then it forms a lake-like structure. Then we call it as a karst lake. Then karst window formed due to collapse of upper surface of sinkholes or dolines, and this enable investigator to observe subsurface drainage easily. So here the upper surface is collapsing. Because of that, this window like structure is formed. Suppose here the upper structure is collapsing, this because of the collapse of the structure, we can easily, it is visible, it becomes more visible. Then investigation can see that subsurface, suppose the drainage system, suppose the water is flowing like this and it is entering here, or it is flowing under the surface, ground surface, it is flowing like that, then easily it can be observed. So that's how karst windows are formed, because of the collapse of upper surface of sinkholes or dolines. Overlaps or compound sinks, these are extensive depressions up to 1 kilometer across. They are formed due to coalescence of several dolines or sinkholes. So they can be up to 1 kilometer, but they are formed due to coalescence of several sinkholes or dolines. Polges, these are also extensive depressions. Their character is like steep sided walls, flat alluvial valley floors, independent surface drainage system on their floors, central lake, etc. Shape, elliptical shape. Area is up to 250 square kilometers. Formed due to downfolding and downfaulting of limestone topography. So polges, in this image we can see it's a larger, it is so when we compare with the other features, so even the uvula is a larger structure. When we compare with uvula, polges are much more, up to 250 square kilometers. It can aerial extent, it can be of up to 250 kilometers. And these depressions are, it has a steep sidal walls, we can see here it has a steep sidal walls. The valley floor, it can have alluvial deposition can be there on the valley floors. So these structures are called polges, and it was in elliptical shape. Valleys of karst region, in the karst plain region, surface drainage system develops various valley forms. So these valley forms are called, the main valley forms are called sinking creek and blind valley and karst valley. So sinking creek, so these sinking creeks are developed due to development of numerous closely spaced sinkholes. The surface of the karst plain appears like a sieve. So sieve means, so suppose like this, here closely developed sinkholes, small sinkholes are there, so then this region appears like a sieve. So Because of that, the sinkholes act like a funnel and the surface water go underground through this landform. So the water, surface water, suppose surface water is running like this on its path, then it just enter the sinkholes and they run like a subsurface drainage to a certain distance depending upon the aerial extent where the sinking creek is there. So if water disappears in numerous sinkholes located in a line, resultant feature is called sinking creek. So here we can see, suppose this is a sinking creek. Here subsurface water flow is there. Surface water flow is there. This is entering down toward in the sinking hole, and this is flowing like, so suppose here it's coming out this drainage is coming out of a cave. It enters and it flows downwards like a cave like structure. It flows down and it is flowing outside. So this kind of but this needs lot of sinking holes, which has to be very close enough to make such kind of sinking creek kind of valley forms. A blind valley, here we can see, so here earlier water was flowing in this region, but something has prevented water flow now. So that's how blind valley forms, because here surface rivers disappear in the limestone formation through a swallow hole or sinkhole. So earlier it was the water was flowing in this valley. Suddenly some here, suppose a limestone formation like sinkholes, swallow holes develops in this region. In those regions, suddenly the water will flow into this region, and this region becomes dry. This valley becomes dry, then we call it as blind valley. The flow terminates at swallow hole and the valleys looks dry. So next one is Karst Valley. So in this Karst Valley, on limestone formation, surface stream developed their U-shaped valleys. So here surface stream is flowing, but it develops a U-shaped valley. These are also called solution valleys, because here limestone region is there, so it dissolves the limestones when it is flowing because of the erosional work of the river, and it is called as solution valleys, and it is in U-shaped. And these valleys are also temporary due to disappearance of water through sinkholes. So when it is flowing like this, suppose here differential height, because of the differences, suppose here in this region, say this region is flowing up to this, here limestones are there, regions are there, but in this region limestone are just below that, also limestone rocks are there. When it is flowing, suppose it forms here, it develops, so till this valley has developed. So the valley has developed, but here sinkholes develop when, because of that, the river water, the water which is flowing on it just disappear because of this sinkholes, and this region becomes dry. That's how this Karst Valley develops. Next one is caves and caverns. So caves and caverns are formed because of dissolution of the soluble rocks by the erosional activity of groundwater. The size and shape of the caves vary depending upon the availability of the massive rocks, rock structure and lithology of that place. And example, Carlsbad and Mammoth Caves of USA. Next one is Ponores. So Ponores are pipe-like vertical passages that connect the caves, and the swallow holes are called Ponores. So here this is a pipe-like. So here limestone, because of dissolution of limestone rocks, here a pipe-like structure which has formed. These pipe-like structures are called Ponores. This can connect a cave or a swallow holes. And it is also called as caverns, formed due to downward extension of sinkholes. So these are sinkholes. Originally these are sinkholes. They extend because of the erosional activity of the water. They extend and they connect to the cave or swallow holes. So that's how ponors are formed. Natural bridge. So natural bridge are formed due to collapse of the roofs of the caves. So when the roof of the caves are collapsed and the bridge-like structures are formed, and because in sometimes either it can form due to collapse of the roofs of the caves, or sometimes the disappearance of the streams. So sometimes when the stream is flowing like this, suppose it disappears, like in sinkholes or swallow holes, it disappears, and this region becomes a natural bridge. That's how natural bridges are formed. There are many theories to explain about the origin of this landform, and Next one is depositional landform of karst topography. So this collectively, depositional landforms of karst topography are collectively called as speleothemes. So all types of deposits in caverns, these are calcite is common constitute. The common constitute in this cavern topography is called calcite, and thus there are different features are there. So dripstones, these are calcareous deposits form dripping of water in dry caves from them. So suppose this is a cave topography formed by water erosional activity of the groundwater. So dripping like small dripping life topography are formed. These are called dripstones. Suppose columns of dripstone hanging from the ceiling of the wall, so then we call it as stalactite. So columns like that, larger columns, if they are hanging like this, then we call it as stalactite. Suppose this, if it is growing like this from the floor of the cave, then we call it as stalagmite. And suppose here these two stalactites and stalagmites, and they join together to form pillars. And helictites, these are dripstones growing laterally from the stalactites. So suppose a stalactite can itself it grow laterally like this it can grow, or from a stalactite it can grow like this. So these are called helictites, whereas heligmites, these grow like this. Suppose this is a stalagmite, they can grow like this, or when we grow from the valley floor itself, they grow like this, not vertically they don't grow, they form like an angular formation. So they grow like this, so they are called heligmites. And cave pillar, I said, they are formed when the stalactite and stalagmite meet. So these are